Good morning. So we are discussing the okay. So we are discussing the range and null space, right? So last class we had seen some of the elementary properties are some equivalent conditions for your range space of T and the null space of T, right? So let us recall that. Okay, the null space of T. So let's just recall that what was the definition of null space of T and then range space of T. Okay. And we also proved that those two are subspaces of a vector space, right? Sorry, null space of T is the subspace of vector space, but the range of T is the subspace of W, right? So we are also seeing the proof of that. So we just take, okay, this is the definition of your null space of T. Any T is any transformation from V into W. Null space of T is equal to X. Okay, that X will satisfy this condition. T of X is equal to 0. So whatever X satisfies this condition, we take all those collections. That is nothing but your null space of T. And we had just quick, we had seen that it is a subspace because if you take any two vectors, X and Y, if you take, then it is obvious that T of X equal to 0, T of Y is equal to 0. And then from that, since T is linear, so we can write T of X plus Y is equal Tx plus Ty. Since Tx is equal to 0 from this, and then Ty is equal to 0. So 0 plus 0 equal to 0. Okay. So from this, we have that T of X plus Y is equal to 0. If this is true, then by the definition of your null space of T, X plus Y belongs to null space of T. So similarly, one can have this subspace to prove the other condition for the subspace. Okay, X plus Y belongs to null space of T, and then Cx belongs to null space of T. And then one can say that null space of T is a subspace. Okay, similarly, we can have this range space of T, and then one can prove that the range space of T is also a subspace of W. Am I audible?
Yes, sir.
Okay. So last class we had given proof of this also. So we had just written the definition of this. So range space of T is nothing but the set of all W is in W such that W will satisfy W is equal to T of X. Okay, for every X is in V. So now we take W1, W2, we in range of T, but whatever W1, W2 if you take, that will satisfy this condition. W is equal to T of X. So therefore W1 you took in R of T, so therefore W1 will satisfy W1 equal to T of X, and similarly W2 is in range of T, so W2 also will satisfy, let's say, T of Y. This for some X is in V or some Y is in V. Again, making use of the linearity conditions, we easily get that T of X plus Y is equal to W1 plus W2. So that means W1 plus W2 is nothing but T of X plus Y. So which implies that W1 plus W2 belongs to range of T. And the other condition is also straightforward. So therefore, again, it is very clear that the range of T is a subspace of V. Injective map and then surjective map, one and R2 map, and that's definition is that's a similar definition to the function.